So the process to find the vertex of the graph of a quadratic function in standard form using method 2 involves finding the x-coordinate of the vertex by using the vertex formula, which is x equaling negative b over 2a. Then we find the y-coordinate of the vertex by evaluating f at the value found in step 1. That is, we find f of negative b over 2a. So the first thing we're going to do is find the vertex of g of x equaling x squared minus 4x plus 7. So the first thing we need to do is figure out what my a is equal to, what my b is equal to, and for practice we'll just find out what c is equal to as well. So a is the coefficient of my leading term, or the coefficient of x squared, so a in this case is 1. B is the number attached to x, so b in this case will be negative 4. And for practice, c is the constant term, which in this case is 7. So to find the x-coordinate of the vertex, I take negative b over 2a. So I take negative 4 over 2 times 1, which gives me 4 over 2, or 2. So the x-coordinate of my vertex is 2. To find the y-coordinate, we find f of 2. So I take, or g of 2 in this case, so g of 2. So g of 2 is going to be equal to 2 squared minus 4 times 2 plus 7. So this is going to be equal to 3. So the vertex is 2, 3. And that's all we were looking for in this example. So now we'll try to sketch a graph using method 2. So I want to sketch a graph of f of x equaling 2x squared plus 10x plus 7. So the first thing I'll do is find the vertex. So first I need to identify what my a is equal to, what my b is equal to, and what my c is equal to. So a is the leading coefficient, so in this case it's 2. B is the number attached to x, so a positive 10. C is the constant term, which in this case is 7. So the x value of my vertex is negative b over 2a, which will be negative 10 over 2 times 2. So I end up with negative 10 over 4, or negative 2.5. So the x-coordinate of the vertex is negative 2.5. To find the y-coordinate, we find f of negative 2.5. So f of negative 2.5 is equal to negative 5.5. So the vertex is negative 2.5, comma negative 5.5. We find additional input-output pairs of f. So we need to find other points to plug into this function. So let's evaluate this function at different coordinates. So let's evaluate it at, make a table. So I have some x values of, let's do negative 4, negative 3, negative 2, and negative 1, just to get a little scattering so I have some shape of what this would look like. So f of these values, if I take f of negative 4, I would have 2 times negative 4 squared plus 10 times negative 4 plus 7, and that ends up giving me negative 1. I could do the same for 3, I'd end up with negative 5. At negative 2, I'd also end up with negative 5, and at negative 1, I'd end up with negative 1. So now I have a table of values that I could also use to graph this function. So I plot these points and connect them with a smooth curve. Notice that my leading coefficient is positive, so my parabola should be upward facing. So here are the points plotted and the sketch of my parabola.